Welcome students. Today is the penultimate class on digital land surveying and mapping. Today I am going to discuss on how to prepare the data for making the map using some particular software. Now this class will be discussed under the following heads. First I will introduce, then the data preparation. Actually data preparation will be done under 3 heads: transformation, reduction and conversion, and then map making. I will show you how to make the planimetric map using a software, then contouring using another software, then how both these map has to be registered or to convert it to topographic map, followed by further discussion. Last few classes I have discussed about the data collection, and the end product of the data collection is to have the digital data. Now during data collection we have two fundamental parts. One is that GPS surveying, through which we have collected the position of control points. We know that the GPS provides us coordinates or location in WGS coordinate system, and the WGS coordinate may be either in Cartesian system or in geodetic system. Now next part, what we did, we had made use of total station to collect the location of many details along with the object's name. The procedure is that we should collect the GPS based control point, and that will be WGS 84 coordinates, and these WGS 84 coordinates, as I told you, may be Cartesian or in geodetic. Now these WGS 84 coordinates are the global coordinate system and the surface of the earth, which is curved, but the map we will prepare is on a plain paper. So we need to convert these, or we call it transform these WGS 84 coordinates to north, east and orthometric height. Generally we prepare map making use of north, east and orthometric height. Now the WGS 84 coordinates, which is geodetic or Cartesian, that has to be transformed to northeast height, and that can be done through software. So we have our mapping software or also our GPS software which do process the data, and many other softwares are there which may be used to convert the WGS coordinate to north, east and height coordinates. Now these north, east and height, actually this northeast, this is the planimetric, this is planimetric position. That means we do consider it on a plane, and this height is the orthometric height, and this height is above the geoid. Now in order to convert the WGS 84 coordinates to northeastern height, the software demands two information. One is the projection system, to which we have to convert this 3D coordinate into planimetric position, and in GPS WGS 84 system they made use of UTM, universal transverse Mercator projection. So UTM is by default because of we have taken the data from WGS 84 coordinate system, and also we need to define the area for which we like to transform the data. Now, as for example, for our Roorkee, we do have the UTM area 43N, N for north, 43 is the number. So, corresponding to each area you will have a number, and most of India is in the northern hemisphere, so the places in the northern hemisphere they have to give the north. So, this is the information that the software will like to have before converting. Another information that it will like to have is that which geoid you will like to have. Now, generally for WGS84 coordinate system we do make use of the global earth gravitational model EGM 8. So, this is the information that we have to provide to the software, and then software will provide the corresponding to the WGS84 coordinate. Software will provide the northeastern height locations. So, for control points, this is the method how we can get the northeastern height. Now, this location of the control points, we make use of these locations of the control points in the total station. In the last class when we have demonstrated the collection of detailing using total station, then we have shown that some stations has been located whose GPS coordinates are available, and those coordinates are in either in WGS84 coordinate system or NEH. So, if we make use of the NEH coordinate, then all further collection of data will get reduced inside the total station automatically. So, further reduction in data will not be required. So, it is advisable to make use of the local coordinates or northeast height coordinates of the control points to the total station during its backside and station location, and for further detailing, further collection of data, all data for detailing we will have in terms of northeast and edge. Now, in some cases it may not be possible to provide the position of control points in terms of northeastern height, because it needs some software to convert from WGS84 coordinates, and maybe during the field work you will need to carry out your total station surveying, sometimes before control point establishment, sometimes simultaneously. In those cases we will not be able to provide the northeast height coordinate of the control points. So, in that case we have to assume some arbitrary value like 0, 0, 100, something like that for the northeastern height. For the control points, for defined control point we may make use of defined northeastern height like 1000, 2000, 3000, just to have a identification. Also this will provide us the identification from which control point we have done the work. Now, once the work is over, coming back to the office, then after processing the GPS data, then we will have this northeast height corresponding to each of these control stations. Then we can convert all our data for detailing in terms of northeastern height. So that reduction has to be done after the data has been collected, and that is called data reduction indirectly, means we have to do it in our office separately rather than getting the data directly using the total station. So in that way, first we should transform the data, transform GPS CP control point to northeastern height. Now then, either we get in total station for control points. If we provide northeastern height, then we will get the data for detailing. We will be in northeastern height directly. Otherwise, we should go for arbitrary northeastern height for the control points to start with. Coming back to the office, we have to convert those using the control point northeastern height, and then we have to reduce the data. So this is how our data is to be prepared before we go further for our digital map making. Once the data has been transformed and reduced, then we have to identify the software in which we are going to prepare the map. Now in our case, I will take the demonstration. For our demonstration or for my explanation, I have taken AutoCAD as the map for our AutoCAD for planimetric map and surfer for contouring. So my further discussion will be more oriented towards this software, otherwise similar type of operation has to be done for other software also. So by transforming and reduction all our data now in the format of northeastern height, we have two sets of data, one for control points and other for detailing. Now first what we need to do, all these data for AutoCAD, actually we need to have the data in the format of NEH, but our data which we have got from our digital land surveying in the format of north, east and height independently. So we have to put all these together as a single unit. So we have to do it by using the AutoCAD software. First we will transfer our NEH of the control point and detailing in the Excel sheet. So this is the sample data you can see here, sting, northing and height we have taken. So we can open this file. So we will maintain the data in a file, then that data may be opened in an Excel, Microsoft Excel, and once that data is there, so we can put it to in three columns. After that we may make use of a formula called palette, and from there is a text command in it. In the text command there will be a option called concatenate. So if I can concatenate these sting, northing and height in another cell, in that way we can convert the independent north, east and height. These are the three columns in an Excel sheet. By using the concatenate command or option, we can make these data in this format. So that is what is shown here. So once the data is available, So we have got converted this XYZ or northeast height to our this format. Then all these data may be copied as a combined cell for further use. So this is the way how we have to convert the data in the format, the way our AutoCAD software will consider. Now once the data is available in that format, then we will like to open our AutoCAD software. Now AutoCAD, there are varieties of AutoCAD software. AutoCAD 3D Civil is a software which is provided to students free of cost. So the student version may be procured by any student for his academic work, and that will be given to you free of cost. So I will suggest all of you to register for that software and get yourself accustomed to working with that software, and specifically for mapping purpose. In fact, AutoCAD 3D Civil directly provides all the 3 dimensions. That means both planimetric work as well as mapping work can be done. However, I will be doing here using independently AutoCAD for planimetric, Surfer for contouring. The reason behind is that I have found that Surfer provides contouring far superior than what it provided by the AutoCAD 3D Civil. Anyway, now after opening the AutoCAD software, first we have to make use of the grid option available in the AutoCAD software, and that we can draw the grid at some appropriate scale. So gridding and scaling has been done now. Then we should go for the click command. There is a command available in the software which is called point. So you click it, and then we should first select the control points from the file, and then we paste it. It is shown here in this. So once we paste it, then the points will be displayed in the display window. So in that way we can get the position of the control point, and we may make use of very faint line to join the control points, and that will provide us the network of control points, because that will serve as the base of our mapping. Now we should also look into whether our network shape is same as that available in the field or not. If it is, fine. If it is not, then we have to revisit to our whole work, so that the control points are being placed as they are in the field. So once control points has been satisfactorily plotted and the network has been defined, then we can go for the points of the detailing, and we see in the similar way we just select the points, we paste it, and then all those points will appear in the display map. Then we have to identify each and every point, and we have to classify ourselves whether the points belong to point object or line object or area object. So for the point object, we should identify not only the location of the point, also we should know what feature we should go for, what is the feature of that, and corresponding symbols we should locate, we should note down during corresponding to that point. So in that way all the point object has to be represented by its symbol, then line objects, so all the points which belong to the same line has to be joined using the line command that is available in the software, and also we have to make use of the corresponding symbol to represent the object. Finally, we should also locate the point which are belong to a particular area, so we should add all those points and also make use of symbols, and also if sometimes we need to go for text, so all those text we have to do. In that way we can prepare our planimetric map, and after preparing the planimetric map also we have to go for other cartographic elements like scale, then our legend set, then our north direction. So that can be done once the north planimetric mapping has been done, or we can also do after the topographic map has been prepared. So next thing we can do also the making use of surfer package. So for contouring, so whenever we will go next we will open the surfer package, and once in the surfer package again similarly we will go for the grid module, and we will prepare the grid to the scale which we want to have, and then after preparing the grid we will click to data may be obtained through our file, and then this we have to define in which direction we want to give the northing, easting and elevation or height, and then after that we should go for gridding method, and then we should click the grid report. So simply by doing it we will be able to get next point. We have to go to the map, and from the map we will go to the contour map, and we can get new contour map, then we will get the contour of the area. So the work is very simple, but we have to be conscious about the type of interpolation taking that the software provides us, and we have to go on changing that thing till we get the contours as appropriately represents our area. So once the contour has been prepared, then and also planimetric map has been prepared, then the next work is to be done is to superimpose these two, because ultimately it is the topographic map which really we want to prepare, and the topographic map contains both the planimetric positions of the objects along with their symbols as well as contours with the contour value. Now this thing we should do by making these two maps. The two maps we will have the control points as I already told, and having the grids. So by matching the grids as well as control points, we can superimpose one above the other. That is a process called registering or registration. So there are so many softwares also available, independent softwares are available. Also this work can be done by making use of AutoCAD software. So one planimetric map can be superimposed on the surfer map, or surfer map may be superimposed on the planimetric map. We can make use of AutoCAD software, we can make use of some other software, and we have to ensure that they are registered properly. And to ensure register, the best way is to take care of the control point overlapping as well as weights having the same scale. In that way, whenever we will get the superimposed map, then we can say that our draft map for the topography has been prepared. So then we can go for scaling, as I told you in the last class, some other class, that there are two types of scaling we need to have represent. One is that graphical mode, another is the RF mode. Then we should go for the legend chart, we should have the north direction, we need to have the different text has to be written. So all those cartographic work has to be completed, and each one of the symbol should be noted down having the proper color. Contours should be noted with proper color, and every fifth contour should be a bit more thick, and contour should be identified along with the contour value. So in that way we can complete our work, and the draft one we should compare with the actual field whether all the objects which really we want to have to be represented in the map are available or not. If not, we should go on editing till we are satisfied with the elements to be represented, as well as we should also know what are the way the reliefs available in the field is also should be represented in our map, and whether it is represented in the map properly or not. If it is, fine. If it is not, then we have to see whether there is a problem with the data or with the interpolation technique with the mapping. So all those issues has to be resolved before we make it as a final map. Once the map is final, then we should take the map print out using automated plotter, and also we will have the map in digital format. So that is the digital map, and the beauty of digital map that we can change the scale whatever way we like. If the data is of sufficiently high quality, then the quality of the map will be maintained, and also we will be able to take the printout output of the map to the size whichever we will require. So in that way we can prepare the digital map. So with this I like to conclude my classes on digital land surveying and mapping, and the next class I will like to tell you about the whole of the course, about how this course is being planned, so that you can have a feeling this how the connectivity comes and ultimately lead to have the knowledge about the digital land surveying and mapping. Thank you.